Thanks for joining us in this inaugural talk in our virtual digital economy seminar. I hope you're not yet tired of talking to your computers about research, but I think today's speaker will help spice up our lives a little bit. So very briefly, the rules for today. The moderator will be Luis Aguiar at the University of Zurich. And I'd like to thank him very much for taking this role in this first session. So please be patient with us and be patient with him and also with us as we try this new format. If you have clarification questions during the talk, send these to Luis in the chat window. He will either ask the question to the speaker directly or unmute you to ask the question yourself. For the Q&A after the talk, we'll collect questions in the same way. One final announcement, the seminar will be recorded. So if you do ask a question yourself, you will be on the recording. All right, so I'm very excited to hand this over to Luis.
Thank you very much, Hannes. So welcome, everyone. Good afternoon or good morning, depending on where you're located. So our first speaker today is going to be Joel Waldfogel, who is at the University of Minnesota. He's going to present joint work with Imke Reimers, who is also in the audience, so you can also ask her questions during the Q&A. She's a professor at the Northeastern University, and the paper that's going to be presented by Joel today is called Digitization and Pre-Purchase Information, the Causal and Welfare Impacts of Reviews and Crowd Ratings. So very much looking forward to this talk. And Joel, the floor is yours.
Well, thank you very much. It's really a pleasure to be here. I guess by here I mean in my daughter's bedroom, but it's a pleasure to be here virtually. And you know, I think before I get started, I have to acknowledge the situation that brings us here, and it reminds me of this famous quote in Annie Hall about the world being divided between the horrible and the miserable, and the horrible is terminal cases and things like that, and the miserable is everything else. So today, what I hope is I can give us an hour of merely miserable time amidst the whatever else is going on. Okay, so as thanks again, and as Luis said, this is joint work with Imke Reimers. So the paper, yes, digitization and pre-purchase information. I guess you can read that as well as I. So the background here is really about digitization. Digitization means a lot of things, but certainly it has lowered the cost of production and distribution for creative products, and there are a lot more products available as a result. I just have a picture here from a JEP paper I wrote a couple of years ago, just growth, huge growth in the numbers of new products in essentially all creative product categories. And as I've worked on with Luis and others, I think the welfare gains available from these products are really substantial. And a lot of this work was summarized in the book I published a few years ago, Digital Renaissance. There's a plug for myself. But having said all that, though, what really wasn't addressed much in that work is the question of how people find the products and how, products that might be useful to them. And product discovery is a really growing problem. And with so many new products, this is an important issue. And moreover, for products that are experience goods, it's really important to have information prior to purchase. So that's really the context that this paper is addressing. Now, in particular, we're going to be looking at books. And when you think about product discovery in books, traditionally, it's really been undertaken by professional reviewers. Professional reviewers publishing in places like the New York Times. The New York Times will turn out to have a really special role here in the US book market, but I'll get to that in a bit. And the thing about professional reviewers is, although there are lots of reviews out there, it's really a very small number of products that get reviewed in relation to the total number of products released. That was always true, but it's especially true now with the great growth in new products. But when you think about digitization, now the word gets to mean a different thing. Digitization, in addition to changing the conditions under which products are created and distributed, also has changed the information context of products. So since digitization, in addition to professional reviewers, we have crowd-based ratings. And we're going to be thinking here a lot about Amazon star ratings. You can probably think of other crowd-based ratings, but the thing about crowd-based rating is that all products get reviewed. And so, and we'll give you some details about that in a bit. But the fact that all products are getting reviewed might allow realization of some of the welfare gains from new product discovery. And what we're really going to be about here is comparing the new digitally enabled sources of information as sources of welfare gain compared to the traditional sources of information. Okay, so the big question, I guess, is how has digitization changed pre-purchase information and its effect on welfare? But specifically, we'll be asking the following questions. What are the causal impacts of professional reviews and crowd ratings on sales and demand? And you know, kind of a subsidiary question there is, how does digitization affect what types of products are both promoted by virtue of being reviewed and consumed? And then a second broad question, how do ratings and reviews affect welfare, and how has this changed with digitization? So we have to go a little bit beyond just, are there causal impacts, to try to map that into welfare and an actual horse race comparing the welfare impacts of the traditional sources of information with the digital sources or digitization-based sources of information. And we'll look at this in the context of books. Now, a few things to say about kind of why we're doing the things we're doing. So first of all, I think you need to ask of us that we have some kind of credible way to draw some causal inference about the effects of reviews and ratings on demand. But then to go beyond that and to say something about welfare, we need to do some additional things. We need some kind of structure. So we're going to have a structural model, I mean, in sort of a lightly structural, but a structural approach that allows us to take those causal estimates and say something about welfare. But that in turn requires some translational work to take those estimates, and I'll talk a lot about that as we go. Now, since I think I'll get through all this stuff, since you aren't really allowed to ask questions, so I'm sure I'll get through, but just to give you a preview now. So what are the causal? We're going to find that these are sizable and positive, these causal impacts of both reviews and ratings on welfare. And to give away the punchline early, but when we quantify it and put it into the horse race, we're actually going to find the effects of star ratings are quite a bit larger on welfare, about 15 times as large as the effects of even the most kind of important professional reviews. I mean, and I mean this as a group, the welfare effects of the star ratings versus as a group, the welfare effects of the professional reviews. But the other thing that we'll talk a bit about is whether these effects of the traditional arbiters, the professional reviewers, whether those have changed with digitization. You know, you might imagine that digitization would undermine their effects because there's ubiquitous information elsewhere. And again, to give away the answer early, we're going to find that the effects actually haven't waned at all. Okay, so let's slow down and talk about the actual paper, a little bit of background about the information environment in this product market. Because you can think about the reviewing ecosystem as having a couple of parts. There's the consumer-facing part in the US that's largely newspapers. New York Times is special. I'll show you that in a minute. But we're also going to be looking at the Boston Globe, the Chicago Tribune, the LA Times, San Francisco Chronicle, and so forth. That's with the Wall Street Journal. There's also a kind of a business-to-business review sector, which is things like Kirkus and Publishers Weekly and Library Journal. Now they're interesting because they review a lot of books, but they have almost no consumer exposure. You look at the measures of like web visits and so forth. They're really business-to-business things. So we're not going to study their impacts. We don't think they would have any impact directly, anyways. So that's the review environment. Now there are also amateur reviews, and this paper says only a little bit about that. There are, reviewers who review at Goodreads. There's an interesting subculture of people who review books on YouTube. They're called booktubers or YouTubers or something. Sounds like something that you grow a flower out of. But anyways, and we actually did spend a bunch of time studying them and found they had almost no impact. It's in an appendix, but we won't really talk about that today. On the crowd side, as I already mentioned, star ratings at Amazon is what we'll be focusing on because of the importance of the Amazon platform and the fact that we have data on the Amazon platform. Okay, so a little more about these. The New York Times reviews about 1,000 books a year. And if you look at the kind of cross the distribution of books reviewed by New York Times and these other major outlets, the New York Times is reviewing about 80% of the titles reviewed by any of the major US papers. So it is kind of a big deal. But as I say, we'll have data on both Times and these other listed newspapers. On the star rating side, as I mentioned, all books have star ratings. And when a book emerges, it has 0 ratings. Now, on average, by the end of our sample, at the end of 2018, books have 326 ratings. These ratings, and I'll get to more about the data in a bit, but these ratings are not merely product specific, but they're platform specific. So a particular book sold in the Amazon platform, the US versus Canada, can have different ratings. All right, enough about the data. At least for a relatively short presentation. So a little bit of theory to guide how we're going to be asking this horse race question about welfare. Now, what we're drawing on here is this approach to welfare analysis that makes a distinction between ex ante and ex post utility. So this is not original to us, but we think it's kind of a neat approach, and we'll give credit where credit's due. So the idea is that consumers make decisions based on what they know. You could call their expected utility of a product, and they have some guess about its quality. We're going to use R to think about ratings and quality. So if ratings were available, then prior to purchase, people would know the true R. But if ratings weren't available, which is the counterfactual situation when we remove the ratings that exist, then people have to rely instead on their guess about how good the book might have been, which we'll call R hat. And so the idea is that making ratings or reviews available, making pre-purchase information available, can increase book sales for the books where the true quality that would have been revealed by the ratings is better than the guess, or it could decrease sales where the true quality revealed by the ratings is less than what people would have guessed. But here, something important, it doesn't change the utility from consumption. So our perspective on this is that although in the absence of information, people might consume the wrong quantity, too much or too little, they would get the utility they would get. Just, we think people are smart enough to figure out how good something is when they actually consume it. So in diagrams, then, we could think about it this way. This is the context in which the true quality is better than the guess, so consuming it would give a positive surprise. Now, if pre-purchase information were available, people would consume, in some sense, the right amount, and their consumer surplus would be the yellow region here, A plus B plus C. But in the absence of pre-purchase information, they would guess that it's in the situation where R hat is less than R, they would consume too little. They as a group would consume Q1 of this particular book. Now, what would they get as consumer surplus? Here's where it's a tiny bit tricky. They don't get A because when they consume it, although they've consumed the wrong amount, they realize how good it is. So they get A plus B. But what that means for us is that the effect of making pre-purchase information available to consumers, again, prior to purchase by construction, is the triangle C. So that's the change in consumer surplus, is that deadweight loss triangle C. Now, there's an analogous case where instead of the truth being better than expected, the truth is worse and the book is disappointing, in which case the benefit of pre-purchase information is a region D in this diagram. So that's really the theoretical setup. And giving credit where credit's due, Jin and Sorensen implemented this pretty early. Hunt Alcott has a paper, Ken Train has a paper. So it's not original to us, but it's I think an approach to thinking about utility that's I think useful for for experience goods. All right, getting used to two screens here. There we go. So a little more about the data, some specifics. The underlying data set that we have here is 4,283 titles. And to be clear, titles have potentially multiple editions, so there are more editions than titles. And the chronological context is 2018. The way we put together the sample was as follows. We started with all books that made it into the USA Today weekly top 50 during 2018. Now, since books remain on the list for potentially a long time, that's only 1,901 titles. We supplemented that with all books that were reviewed in those major professional news outlets. That's 1,076 titles, some of which, of course, overlap, but not all of which overlap the New York, the USA Today subsample. We also wanted some coverage of, kind of across the distribution, not, far away from the head, neither at the head according to sales, nor at the head according to critical attention. So we took a large sample of books that had been reviewed by highly followed lay reviewers at Goodreads. And so those are really kind of all over the map in the distribution. Some are at the high end, some are at the low end. That's another 2,222 titles. So that's how we put together the sample. Now for each, and by the way, all of what we study is physical titles. The data that we have from Keepa only cover well, I'll get to that in a second, but just the Amazon daily sales ranks of physical books. But what we have is daily sales ranks, prices, the star ratings, and then from the newspapers and stuff, we have the timing of those professional reviews for all those titles mentioned above for three domains, 3 English language domains, or largely English language, sorry, Montreal, Amazon US, Canada, and Great Britain. Now for each book, we also have a little bit of additional information, the genre, the publisher, the author history, which by the way, we'll use to try to form these guesses of how good the books, how good consumers would have thought the books were in the absence of pre-purchase information, in the absence of star ratings in particular. Okay, before we get to any more kind of involved analysis. One thing that's interesting to look at just almost from the raw data is just what sorts of books are reviewed by professional reviewers versus the distribution of books in the sample overall. And it's not surprising, but it's a little bit interesting that professional reviewers focus much more on serious, so-called serious genres. So at the left side of this bar chart, we have political science, biography and autobiography, history, social science. Those are the things that are more common among the professionally reviewed books than among books generally in our sample. And at the very other end of the distribution, again, in some sense, no surprise, but it's always nice when data conform to expectation. Juvenile fiction, cooking, self-help, and romance fiction. So that's what the professionals aren't focusing on. But again, I mean, it's funny, but it's also interesting because that means there are entire kind of constituencies of books and potentially consumers who aren't getting the benefit or weren't prior to digitization, getting the benefit of pre-purchase information. All right, so let's get to the stuff about measuring effects. And I guess there's no, normally, this is the point where you try to sort of make sure everybody's with you, but I guess I'll be told by the organizers if something horrible is going on. Yeah? Okay, fine. So a little bit of a roadmap of what comes next here. We need to, as I said, estimate the causal impacts of professional reviews and crowd ratings. So we'll do that, and that takes some effort with that. And then some effort to translate those elasticities of ranks with respect to, say, star ratings into effects on quantities, to turn those into things like price elasticity of demand, rank elasticity of demand, stuff like that. But then also, then the structural part where we use those elasticity numbers and translate them via logit models into welfare estimates. So that's the three chunks of what comes next. So for the causal impact of reviews on ratings, we have a couple of different identification strategies adapted to the couple of different kinds of information sources we study. Professional reviews really are isolated events. On a particular day, a review appears in, say, the New York Times, and we treat those as discontinuous jumps in attention. So we'll be looking not just, but at high frequency data on the sales ranks of the books before and after they get a review. That's really basically the approach. We'll control for more than that, but that's really the idea. And I should also have mentioned when we, talked a little bit about data, and we haven't really, in a talk of this length, talked much about existing literature. There are some nice papers out there measuring impacts of reviews and so forth. What they by and large use is weekly Nielsen data. That's sort of the best data people have. Our data are in some respects much better because they're daily, but in some respects they're worse because they're ranks and not quantities, which is why we have to do that translation. But because we have daily data, this idea of looking at a high frequency potential change in the rank with the precise date of appearance of a review is potentially compelling, and when you see the pictures, maybe you'll be convinced of that. So that's the approach on that. The approach on star ratings is a little different. So here, these star ratings are evolving kind of continuously-ish. They're actually not literally continuous because they're only reported to one decimal place at Amazon. And actually, if you look at the stars, the visual stars are only reported in half stars. So it's not, but still, it's sort of slow-moving and endogenous-ish over time. Surely endogenous across books if you were just thinking about a cross-section. But what we want to trade on here is and build on this empirical strategy that Chevalier and Maison used in a very neat paper where they had two platforms. They had Amazon and Barnes and Noble, and so they could say for the same title, if the star rating was different at one platform versus another, is the sales rank different at one platform versus another? And we actually go beyond that to actually ask, well, what about the change in star rating at one platform for one title versus the change in star rating for that same title at a different platform? And we have thousands of titles and hundreds and hundreds of days, so we actually kind of have a lot of data for implementing those approaches. So we implement approaches that are conceptually very much like that. I'll talk a little bit more about the details in a slide. There is a part of the paper, not much of the talk today, where we do a little bit with those half stars. It's not quite like the Yelp context that Luca interestingly exploits, but it's a little bit like that. At those, as your star rating goes from 3.2 to 3.3, your number of visual stars goes from 3 to 3.5. So in some analysis that I won't really be talking about, we do see that there's sort of bigger jumps at those points. But anyways, let me put that aside, except as a teaser. All right, so what we literally do is to estimate models like the following model. So where little rjt is the rank for title J at day T, And there are also country subscripts that should be floating around here. I think, yes, sorry about that. But we include a lag value. So let me talk a little bit about what's going on here. So we have a lag value of the rank on the right-hand side. Why is that? Well, it turns out that Amazon sales ranks are not simply the sales rank this hour. They're a moving average, and it's a secret formula, but it's one can infer that the following is true, and other authors have noted it as well. What happens, those sales ranks are long memory moving averages of sales over the past, not entirely clear how long. And so the way we deal with that is to include a lag dependent variable in the regression. And by the way, it's very important. If we don't include that, we get massive overestimates of the effects, because it looks like things, it looks like something lasts a long time, when in fact it's just the memory of the dependent variable itself. Now, what else? We also have country-specific title fixed effects. So it allows the title's popularity or appeal to vary across country. Then we have time since publication dummies to control. So we're flexible about that, to control for the time until and since publication. And by the way, I say until and since because Amazon sells books before they're published. You can pre-order them. So it wasn't a misstatement. It's a weird fact. And then what's in some sense the variable of interest is the days, and it really is days until and days since the appearance of one of these professional reviews. And we'll estimate it separately for the New York Times and then the collected other professional newspaper outlets. Then in the broad setup, then we also have the price of the book and the Amazon star rating of the book, and those prices vary by title, country, and time, as do those star ratings. And the intuitive version of the identification strategy I described in reference to Chevalier and Maislin is implicitly or explicitly how we're getting those coefficients. Okay, so a picture. Here is that set of coefficients about, I guess it's those coefficients H. Basically, this is the New York Times review effect. So prior to the review appearing, there's no effect, 0. That's comforting. And then when the review appears, there's a big drop, and that's a reduction in a ranking rather is an increase in sales. And then it converges back up. It's back up by, I don't know, depends how you want to think about it, something like 20, 30, 50 days. Okay. If you look at the other professional outlets collectively, the effect is much smaller. So here we've chosen the axis to be the same size axis as above. You can see does seem to be an effect, but it's a good deal smaller, and it's not quite as long-lived. These estimates, by the way, are just based on the US data alone, which actually makes a lot of sense because these outlets don't really have much influence outside the US. And we check for that, but that's not really where they have their influence. Okay. Now, here's an interesting thing to think about. In principle, pre-purchase information could be positive or negative, and certainly with Amazon stars, they could be better than you expected or worse than you expected. And what turns out with the reviews, we do have a way of saying which reviews are at least more positive than others. What we can do is the New York Times, every Friday, gives a list of so-called recommended titles. These are titles that they reviewed sometime in the last few weeks, but which they recommend. And so the recommended list is 7 to a dozen titles. It's about 40% on average of titles they've reviewed recently that they say are recommended. And let's treat those as more highly recommended books and the others as less recommended. It's not that the others are said to be bad, but they're less recommended. If you do that, and then you take the data, and instead of estimating day-by-day effects, you aggregate to the first 5 days, next 5 days, and then the 11th to 20th day. What you get is the following. First of all, not surprisingly, given the picture, that the effects decline over time. But secondly, the effects are smaller, but still positive for the books that aren't recommended. So all of our review effects are positive, but they're smaller for the books that are less recommended. All right, so the price and star rating effects are those coming. I mean, these are all coming from the same estimates, but now let's highlight those effects of interest to us that'll be important. We have two broad sets of estimates. The first 3 columns just use the US data. So they're just making use of a title fixed effect and the variation over time within title or edition to identify price effects and to identify rating effects. The next 2 columns use all 3 countries together, and so the identification comes not just from a within title variation in the price and within title variation in the star rating, but also this change in rating in one country versus in other countries. I say all that, although if you stare at this table, the coefficients are by and large pretty similar, regardless of which way you do it. But let me focus a bit on particular variables of interest. So the price effect, it's on the order of 0.19. So again, just what does that say? A higher price gives you a worse rank. So that's like, ooh, okay, the demand curve slopes downward. That's always good news. The star rating, which is in some sense of great interest to us, although everything's of some interest to us. Higher star rating improves the rank. So a higher star rating means it gets smaller, so sales increase. That does seem to make sense. We also, and this turns out to be important, looked at the interaction between the number of ratings and the star rating, because it's easy to think that people would pay more attention to a star rating based on more ratings than a star rating based on fewer ratings. And indeed, if you include that interaction, it's very important. It takes the star rating effect itself, and the star rating effect itself actually literally goes to about 0, but the interaction is quite big. Now, since we're going to lean on that, we thought we should really explore it. So what we did is we go.
Yep, we just have a few clarification questions.
You bet.
So, so there's one from an India Goose. So let me just unmute him so that he can perhaps ask his question.
Cool.
Oh, we can ask you verbally? Okay. Hey,
Yes.
yeah.
Hey.
Hey, yeah, I was just curious, how several papers have used the Pareto mapping distribution from sales rank to demand when they estimated demand. So I was curious, why you haven't taken that approach.
So you mean prior to, so what we do is we take that approach, but we take it after the fact. So it's going to come into our translation of the, we're going to estimate an elasticity of rank with respect to, say, star ratings, but then we're going to turn that into an elasticity of quantity with respect to star ratings with some fragmentary data that we have on the relationship between quantities sold and ranks.
Okay, so it's coming.
So so it's coming. We're gonna use it. Yeah.
Sure. All right. Thanks.
And we have another clarification question from Shrabasti. Let me unmute the mic as well.
The loss in value also you have by running a hypothesis test for longer, which is
You're muted.
Yeah, you just muted your mic. Okay.
The connection was a little weak. Maybe he could email it or text it or something, because I'd like to hear it. But
well, again, so let me read it. So the question is, how is the model estimated? And it says, given we have a lag dependent variable as a covariate, usual fixed effects estimation might not be appropriate.
yeah, so there is this, but remember that's really a concern with short panels. So it is true, if you take the panel down to 2 observations, you get a crazy coefficient, but our panel has hundreds of observations in it. So that problem just eliminates itself when you have more than about 50 observations, and we have hundreds per title country. But it's a good question. I mean, there's a little discussion of it in the paper, or at least there was.
Yeah. All right. Thanks.
Should I proceed? Okay, I'll keep going. So I wanted to talk again. We're leaning a fair. Oh,
wait, there's one more question for
sure.
From Hannes, actually. Hannes, I think you can unmute yourself. Is that right?
The question came from Marc Bureau. Can you let him talk?
Please.
Yes, let me find him. Oh, this is fun.
Am I late on a referee report? Don't let him talk.
Hi, Joel. So a quick question about the log of reviews coefficient. So if I remember well, in Chevalier and Meslin's paper, they find a positive effect of the number of reviews on sales, and you seem to find a negative effect.
Yeah. Well, we also we're going to so we have both the number of reviews, the number of ratings, and then the interaction. And it's going to turn out that the interaction is quite important. Let's allow this to come out in the context of what I'm about to say, and then I'll be happy to revisit it. Okay, so if we're going to lean on this, I'd like to not lean on functional form and see that it, it's actually turns out to be true. So what we did is took the number of reviews variable and just divided it into deciles, and so estimated the log rank effect separately by decile. And these are, to my eye, to our eye, very, very remarkably linear. So the linear specification doesn't seem to do any violence to what's actually going on in the data. Okay, so broad step two then is to translate these coefficients into demand elasticities. And this speaks to Anindya's question. And I think, anyway, so we start with some specification broadly like what's bold on the top of this slide. And so we have a couple of steps we have to do. One is to turn the ranks into quantities. Ideally we'd have quantity data and do this directly. Instead, what we have is we have weekly Nielsen data. So we have the top 100 titles, physical titles in Nielsen, I think during the year 2018. And so we can estimate the relationship between basically a regression of log quantity on log rank. And it turns out that the coefficient B is about 0.54. It's not, sometimes when people don't have data, they'll just implicitly assume that it's 1, and it's about minus 0.54. Now, to be clear, Nielsen is not Amazon. We don't have the Amazon data. They don't share it with anyone, but we're going to go ahead and use that 0.54. It is comforting that things that sell a lot in Nielsen also sell a lot in our samples. So it's not that our data are crazily wrong. And moreover, I didn't mention this, but so the year for which we could get this aggregate statistic was 2017. Amazon accounted for 45% of physical book sales in the US. So it's not a small sample of the stuff that we can study. Anyway, so step one, to turn ranks into quantities, this elasticity is 0.54. But step two is to also then worry about the moving average property of the Amazon sales ranks. So we make this steady state assumption, RJT equals RJT lag 1. And then the elasticities, for example, the price elasticity would be then B, and B is this 0.54 number from the Nielsen data. A is the coefficient on price from this basic regression approach, and 1 minus theta, well, theta is the coefficient on the lag dependent variable. And so we calculate the price elasticity and the rank elasticity in these analogous ways. And with the rank elasticity, because it varies by the number of ratings, we'll be calculating sort of a series of those. It's not just a scalar, but it depends on how many times the book has been rated. So then, doing these translations, we can get some numbers that at least we can think about. And these are those numbers. On the left-hand side, we have the price elasticity. This price elasticity is at first glance, kind of shockingly inelastic. It's minus 0.4, which just seems almost crazy. Although, other studies find similar numbers. And when Jeff Bezos is interviewed on 60 Minutes, and he says things like, and literally, it's a great interview, go watch it and show it to your students. He says, yeah, all the numbers tell us we should charge much higher prices for, and he's talking about physical books, but we want to maintain trust with our customers. So I'm actually, even though it's a very small in absolute value price elasticity, it's in line with other things that we know. And also we'll do some sensitivity analysis of all of our results to different possible price elasticities. Now on the star side, if you don't disaggregate by number of reviews, the average is about 0.7. If you do disaggregate by numbers of reviews, it depends where you are in the distribution. At the 25th percentile of numbers of reviews, it's about 0.5. At the 75th percentile, it's a little bit over 1. That's an elasticity. The impact of the Times and other newspapers, that's a little bit different. So there, what we do is we take those impacts estimated from these 5-day chunks, the first 5 days, the next 5 days, the next 10 days, and we simulate just in a simple way the impact on sales, and then we add up the sales over the entire year to see what's the difference between if the book had and hadn't been reviewed. So on the one hand, the 5-day impact at the Times is huge, 78% change in those 5 days. But these effects don't last all year. So the effect on annual sales, the whole year's sales in the data, is about 5% for getting a New York Times review, about 6% if you get both, that is both a Times and one of the other, Boston Globe or something. And it's just about 0.5% if you just get one of the others. Okay. All right. So with those elasticities and those other estimates that we just showed you on that last slide, we then can go ahead and do some translation. We calibrate some kind of model. So we're going to, just to give away the story early, we're going to be calibrating a nested logit model. Actually, in the slides, just to make exposition easier, we'll just show you in terms of very familiar plain logit formulas. Now, having said that, we've done a lot of sensitivity analysis. It's going to turn out it doesn't matter whether we use nested logit or logit for our answers. So the thing that turns out to be simple for exposition is also pretty close to true. All right, but in order to get estimates of the change in consumer surplus, and again, the whole big counterfactual we're interested in is, all right, we estimate the effects of these things in a world in which they exist. Both New York Times and stuff and Amazon star ratings exist. So what we want to do in the counterfactual is to say, well, what if each of those didn't exist? How much different would welfare be? So in order to do that, we need a couple of things. We need a baseline, that is the real and the existing data, and counterfactual mean utilities of each of the products, and a bunch of utility function parameters. So think about these baseline mean utilities as delta J's. We need those both with, that is status quo, and without pre-purchase information, and that's product specific. Oh, and by the way, we'll do these simulations just on the US data, so we don't have to have other country subscripts floating around. We need a utility function price parameter, so we can turn things into dollars. We also need a utility function parameter on ratings, and that's going to be indexed by title, again, because titles have different numbers of reviews, and we know those vary by numbers of reviews. Then we also need a utility function parameter, a way to map the effect of a New York Times or other review on sales via the mean utility. We need those parameters as well. Now, all the things we just estimated and talked about are clearly quite related to this. So the translation is just a matter of implementing these via some logit formulas. A few other things we need, though, and I'll talk a bit about one of these in particular. We need some expected star rating estimate. That is, if we're going to say what would people have thought of the book if star ratings hadn't existed, it's not right to say they would have thought it was 0, which is like a horrible rating. They would have thought something. And so we have to come up with some kind of model that would characterize what they, basically what they would have thought if they hadn't had access to star ratings. And because there's we're implementing logit, we need some market size and we need the substitution parameter, but I'm going to put those off unless there's burning concern, because they're not going to do much of the work. All right, so the mean utilities in 3 states of the world, the status quo, just from data, is the first formula here. And if we were to take out Amazon stars from the status quo, so we would take the status quo number and then remove the utility function parameter on star ratings times the difference between the realized star rating and the expectation of the star rating. The counterfactual for the case without the professional reviews takes the baseline and removes some parameter reflecting how big that empirical impact of reviews was. So how do we get these? Well, some sort of familiar logit formulas. We have estimated price elasticity of demand, estimated rank elasticity of demand. Let me just talk about those first because they're easy. In standard logit, in plain logit, that price elasticity is equal to alpha times 1 minus S, the share. And I should say, I glossed over this a bit, but I talked about how we translated ranks into sales. After we translated ranks into sales, we were able to then calculate quantities and calculate shares after the fact. So we do have these shares because we made those sort of strong assumptions in the past. Anyways, the point is that this implies that we can infer the alpha, the price parameter, from that epsilon, the elasticity that we have now as an estimate divided by 2 other things that are data. I mean, in fact, this gives us a title-specific alpha, although we don't think that's meaningful. That's purely functional form. So we just average that across titles to get alpha. And also, in reality, we do it with nested logit, but that doesn't turn out to matter much. We do the analogous thing with the gamma J's, the effects of rankings, star ratings on sales quantities. And then we do something related with the book reviews. So there, what we have to do is we have to find the parameter that would basically rationalize, that would solve this equation. So I mean, it's not hard to think about in our context, getting a New York Times review raises your sales. So we have to take out something so that logit gives back how much less your sales would be according to our econometric estimates, and that gives us a title specific. I don't know what that Greek letter is. I forget. Okay, so now I think I should talk a little bit about the expected star rating in the absence of star ratings. So what we do is we look at our data and we have the final at the end of the sample star rating for each book, and we run a regression of that on publisher fixed effects, genre fixed effects, and some dummies reflecting the author's prior experience, how many prior titles has he or she authored. We would grant that's a pretty naive estimate. And by the way, we'll do sensitivity analysis of the results with respect to that because it's quite important. Anyways, we get an R-squared of about 27% in that regression. Okay, so this is the entity we've been after, and we saw this many slides ago. I want to come in on time, but we're after those C and D triangles. That's the kind of the object of interest here. The C and D triangles associated with both professional reviews as well as star ratings. So let me just go to the estimates. So first of all, an interesting sideshow is effects on revenue. So on the star rating side, we have some star ratings are disappointing, or some star ratings are above what had been expected, and some are below what had been expected. And so we have, and it's interesting because just effects on revenue understate effects on welfare, because both being told not to buy things that are bad and being told to buy things that are good are both good, but they don't wash. So it's just kind of an interesting thing to contrast. On the review side, because all of our review effects are positive, they just increase revenue in this context. But what's really of interest to us is the second panel on this table, where we look at the change in consumer surplus. And really, I guess the most important, I think, row for us is that first row of the second panel, the change in consumer surplus, the total. And it's 41 million for the star ratings, and it's about 3 million for the reviews. So that is the basis for our claim that the impact of star ratings on welfare is about 15 times bigger than the impact of reviews. Now, let me say a few things, because a lot of things come up when we get to this slide. So I think, let me speak to some things you're thinking. Well, wait a minute, what about the per title effects? And it does turn out that the per title effects are much more similar across the two sources, but that, of course, the Amazon star ratings are available for every title. So that's clearly the source of this in some sense. So that's obvious once you think of it. But that's also the beauty of digitization, that somehow people leaving this information for others is what's delivering these benefits, as opposed to relying on the professionals who choose a small and selected sample of titles on which to provide information. Okay, so some robustness stuff. The price parameter, I mean, if this were a paper mainly about the price parameter, I think we wouldn't be singing too loudly from the hilltops. But that said, for our big punchline is that one is 15 times bigger than the other. The price parameter washes out of the ratio, so it doesn't even matter for that. It only matters for the absolute size of these effects, which we're not really emphasizing terribly much. But having said that, we're not that apologetic about alpha, because it's not far off of what other sources of information suggest is accurate, even though it's surprisingly inelastic. The substitution parameter, so we do implement nested logit where there's an outside good and then there's just a set of books among which there's substitution. That doesn't matter hardly at all for the results. And it's a little bit of a puzzle to us, although I think we have some intuition. Usually the question of whether sigma matters is a question about whether there's market expansion from something. But here there's market expansion and contraction from being told some books are better than others, some are worse than others. So I think maybe that's why sigma doesn't matter so much. The accuracy of star predictions, though, matters a ton. We don't even need data to talk about that, just an idea. If people already knew exactly how good a book was without star ratings, then star ratings wouldn't change their behavior at all. So in other words, if there were an R-squared of 1 in that regression, in our implementation of that idea, then there would be no welfare effects. So we do have to say something, or feel we should say something about how these results would change if in some sense people had a better idea in the absence of star ratings of how good books actually were. So here we do a little trick that Lisa and I did in another paper, where we say, well, let's take the regression that we had, and then let's add a variable that is the dependent variable itself plus an error term. Then let's take that scalar times that error term and reduce that scalar as that scalar goes as the error term added to the truth declines towards 0, R-squared goes to 100% because we're regressing something on itself. But en route between 100% and the status quo, it's different. So the status quo is 27%. That is, if with the 27% R-squared in the status quo regression, the answer is for the welfare effect of star ratings about 41 million. If there were no ability to predict, it would be about almost 50 million. But as the ability to predict gets better and better, then it would go toward zero. Now, how much ability do people have to guess how good would they have in the absence of star ratings? It's hard to know. So this is kind of a we report and you decide slide. But it would have to be really good to reverse the result that the marquee result of the paper, which is that the digitization-enabled information provides a much bigger effect on welfare than the professional-based information. Okay, and this is quick. Did the effective professionals reviews change over time? For this, we did use the Nielsen data. You know, we took the 100 notable books of the year in the even numbered years. So New York Times has a real pantheon of wonderful books, 100 notable books of the year each year. We took those books in the even numbered years from 2004 to 2018, and we used the Nielsen weekly data, and we essentially replicated what Berger and Sorensen, I forget the other author of that neat paper, just to estimate their effects using Nielsen weekly data, just to see, since we could do that consistently over time. And what's interesting, it doesn't fall over time. I mean, the thought here was, hey, with ubiquitous information, maybe, you know, this will undermine the authority of the traditional arbiters of taste, and the answer is no. In fact, there's an almost puzzlingly large effect of the New York Times in 2018. It's probably got something to do with Mr. Trump and the increased sales of the Times, but it's also a bit of an anomaly. But it's certainly, there's no evidence of a declining impact as digitization has rolled out of traditional authorities on book sales. Okay, so just to bring it in, digitization has delivered more products in a discovery challenge. We have new data, daily data, and causal evidence. Both professional reviews and crowd ratings have causal impacts on sales that are arguably large and detectable. Crowd ratings add substantially to what professionals offer. The total impact of the star ratings about 15 times as large in our baseline estimates as those of reviews. And the effects of the elite traditional gatekeepers does not shrink. So one way to summarize all this is that if digitization brought a problem in the sense of bringing us tons and tons of new products, it also brings a solution in the sense of some kind of product discovery mechanisms that seem to deal with that problem. And with that, I'll stop. Thanks.
All right. Thanks a lot, Joel, for the great presentation, and thank you for keeping time so perfectly. So we have a few questions from the chat. Let's see. So let me take them in order. So there's 3 of those that were asked at the beginning. The first one is from guests, so that's not super helpful, but let me probably so what I'll do, I'll just unmute.
And do you have these in writing? At some point, can you email them to me?
Yeah.
Okay, but I'll take them down too.
Yeah, sure. Let's see. So, where's this? Oh, maybe guests changed their name. That's that's a tricky one. All right, anyway, so let me read out the question out loud. So is the purchase due to rating or recommendation from Amazon given the past tracking record? And then it says that rating could be a proxy for common interest.
For rating, sorry, could be a proxy for what?
For the common interest.
Yeah, so 2 points there. I think there are 2 interesting points in that. One is the way we think these ratings work is that we don't think that people like go to Amazon and say, give me a highly rated book. We think people go to Amazon and they look for something. I want, dragon-based fiction. And then only when they're looking at a particular title is the rating potentially going to have an effect, because there's no place where you can really kind of search by rating. And I don't think that's how people do it. So on the one side, we think that means ratings don't, there's a horizontal aspect to them because you're only looking at this one-dimensional summary once you're looking at particular things. Now, but the other part of the question is how much of what's happening at Amazon is driven by ratings versus other things? I mean, other things are surely huge and invisible to us. I mean, we're tracking the parts that seem to go with ratings. If other things that go with ratings are also, happening at the same time, that would be a problem. It is a little comforting to us that when we look at the discontinuities implied by those visual stars, that something happens there. So unless there's also something else happening discontinuously when your rating goes from 3.2 to 3.3, and therefore your visual stars goes from 3 to 3.5. So I mean, these entirely good point, but I'm less worried about it than I might be.
Right.
Oh, actually, we should bring Imke in if she wants to be worried too.
Oh, that's right. Yeah, let me unmute. Sorry, Imke.
Not to put her on the spot, but
Were you making signs? Because I didn't see you. Sorry. There you go. You're unmuted.
Oh no, now you've unmuted me. So I can just say the same thing. I'm not very worried about this one either. So Joel is doing a wonderful job answering questions.
All right.
I'll give you a toughie next.
Okay.
All right. So then we have a few other questions. So there's one that quite long. Let me find. So GCon had a couple of questions. I think they're still there. Let me unmute your mic.
Yes, thank
yes.
you for the lecture. My first question is, the book is your experience good. In your paper, you give a reason why you choose your book. But how about innovative, some smart good? Because innovative smart good may have a high uncertainty, so people prefer to read your review. And my second question is, Amazon review contents possibly have some fake reviews or suspicious reviews. How you actually try to control for some bias from the fake or suspicious review? Thank you.
So thanks for the question. So let me start with the fake one. One thing we had thought was that we would get all the review data and actually calculate the ratings ourselves, thinking we could, use the literally underlying continuous measure of star ratings. It turns out though, and this I think speaks to both of your questions, it turns out that Amazon does not just do a simple average of ratings, because they downweight some, and I think they literally throw some out, the ones they deem to be fraudulent. So and furthermore, if we think that people are relying on the number that Amazon reports, either the literal to 1 decimal place number or the star rating that they report, then it almost wouldn't matter what the particular reviews said, unless the reviews were so polluted that people didn't trust the ratings at all. So I guess the short answer is we rely on Amazon for having solved their, or at least somehow dealt with their bad review problem, and part of that's explicit in the way that they aggregate that information up to the star rating that they report.
Right. So yeah, thanks. Then we have a question from Xiao Yue. They're still here. Let me unmute them. There we go.
Hi, thank you. It's a wonderful paper and wonderful presentation. My question also overlap a little bit with the fake review, but so my question is, if a review doesn't give a customer the true information or the proper information that works for this customer, that would mean the value will shift downwards instead of upwards. And if this is the case, will your structural model be able to capture the change and the change in consumers' welfare?
So the way I think about this problem, and I'm certainly welcome Imke's thoughts too, but the way I think about this is, so let's suppose that there's a bunch of nonsense in the reviews, fake reviews, whatever, uninformative reviews. If that were true, and it may be true, that would just work against the averages of those reviews, smart averages or stupid averages, having an effect. It would undermine the apparent effectiveness. So I don't think it's a question about the structural model. It's a question about whether we would find an impact of star ratings on sales ranks in the first place. So I take some comfort in the fact that we do seem to fairly robustly, or quite robustly, find these ratings. So I guess, or these impacts of ratings. So I guess that makes me think that even if there are, even if there's information pollution in there, which would be like measurement error, we're still finding stuff.
Yes.
All right,
thank you.
Sorry, yeah, thanks. And then there's a couple of questions that are very related, one from Chiara Farronato and one from Marc Bourreau. They're pretty much the same question. Let me just ask it, which is whether there's some type of complementarity or substitution between expert reviews and crowd reviews, or is there a discontinuous effect in ratings after a New York Times review, for instance?
So we did spend some effort on this. Imke, do you mind if I put you on the spot on this one?
I was really hoping you wouldn't.
Okay. No, so let's see if we can remember. So we were very broadly, we think of the, and I'm just giving you time here, but Imke, but broadly, we think of this question of whether having star ratings in the information environment undermines the effect of reviews as that. But there's also a more proximate way to go about this, to ask, for example, how do the effects of star ratings change after a review occurs? And to a little bit to our surprise, they don't go down, they go up. So there seems to be, do I have this right, Imke? There seems to be complementarity.
Exactly. Yeah, I think it was, the idea is basically that, so exactly after a professional review, the impact of the star rating actually seems to be larger than before. And maybe one reason is because of how people use star ratings in the first place, right? It's this idea that people are going to be more aware of the book in the first place if they have, if there had been a professional review before. And that's the reason why people might even be aware of the book and then look at the star ratings.
Okay. Thanks. Then we have also a question from Tommaso. So let me do so. Let me unmute.
Hi, thank you. Thank you for the presentation. It was really very, very nice. So I was thinking about the role of word of mouth. So before the internet, it was very important what your friends, family was suggesting. So, and I was thinking that maybe is something that would be relevant for the estimation of this head, so the counterfactual, right? So have you thought about that, and how this would affect the welfare effects that you estimate?
So I think we agree that in the absence, it's not that there's no information in the absence of this. There are whatever mechanisms used to exist, people figured stuff out, and even things that reviewers didn't like, somehow people became very popular, and word of mouth is probably important. I guess so let me, and Imke, maybe you have other thoughts, but I mean, it's not as though word of mouth stopped. Word of mouth exists in the factual and counterfactual environment. So for us, I mean, word of mouth is separately of interest for sure, but I think for us, it's something that's kind of part of the environment. I don't know if you have other thoughts about this, Imke.
I think, I mean, that goes somewhere into this our head, as you said, right? It's this idea, we don't know exactly how well people would be able to predict this this quality within the absence of ratings or in the presence of ratings. So that's why we kind of have to leave it up, or we're leaving this up to the reader there a bit.
I mean, I guess one thing we did do that we could talk a little bit about is we spent a bunch of time looking at Goodreads, and Goodreads is more like word of mouth in some sense, partly because you choose one of many people to follow, and they can be socially connected, literally, I think via Facebook. We couldn't really find systematic effects of anything at Goodreads. It was really a struggle to find any impact of anything, which doesn't say word of mouth isn't important. I think it's super important. I just don't think we have the ability to study it. But fortunately, I think it's just ubiquitously there, whether we have digitization or not.
Yeah. Thank you.
All right, so I think we still have time for a couple of questions very briefly. So we have a bunch of great questions here, so let me just take them in order. So there's one by Christos. So let me perhaps unmute you so that you can go ahead and ask it.
Thanks very much. So it's more of a comment rather than a question. So it would be great on your comparison that you did of reviewers, of the welfare effect of reviewers and the stars. It would be good to compare the books, the same books basically. So the books that were starred and reviewed at the same time, because as you said, I mean, the main effect is coming from the number of books that were starred. So it would be interesting to make the comparison for the same books, if I understood you right at that point.
Yeah, we did that, right? So
So yeah, that's how we got to, that's how, at the end of the presentation, Joel was mentioning this, on the per book effect, it's almost the same. I think, what was it? I think the professional reviews were about 50% larger, had about 50% larger effect than the star ratings on a per book level. And because it's a little hard to do it for each book individually, we kind of use just the books for which there are professional reviews and essentially counterfactually removed star ratings from those to get an apples to apples comparison. And that gave us this almost the same, little more effect of a professional review.
All right. All right. So there was, if I take it in order, there was one last comment by Nindya again, which I can unmute you. I think it's more of a suggestion. You can go ahead. Before. Yeah.
Okay, can you hear me?
Yes.
Okay, so so as I'm sure you guys know, over the years there's been a lot of work in the IS and some of the marketing field that has, when you look at the value of information in the textual content of the reviews, and the fact that there's more information in the text than in the ratings. And since you guys are focusing on estimating demand and estimating surplus, I feel like it's important to also, and especially since you're comparing that with professional ratings, it's important and could be useful to look at the value of the text also, because it has been shown in many papers that there is more information in the textual content of the user reviews than in the ratings. And so because users get valuable information from the text over and above the ratings, and sometimes in spite of the ratings, especially because you are estimating demand, might be useful to look at that. And even something nothing super complicated, but even something that involves very basic sentiment analysis or linguistic analysis of the reviews could be useful to get a better precision on the actual surplus.
So that's a neat idea. I guess that would give us a better R squared. Although I guess that, but of course that wouldn't be relevant to our R squared because that's digital information. So it would be, but it would be a different, thing who's enabled by digitization that could have an effect on, yeah. So that it would definitely be useful to us. It wouldn't solve that other problem. It would solve a different problem. Thank you. I don't know, Imke, do you have other thoughts?
No smart ones.
Okay.
All right. So thanks everybody. So I think it's time to wrap up. So for the people who have asked their questions and we haven't had time to cover them, we'll make sure that the authors can get them. So thanks for your attention. Before you leave, Christian just wants to say a couple of things. So that's it on my side. Thanks again, and looking forward.
And by the way, it's really nice to see everyone. It makes me miss seeing people in person a lot more, but it's nice to see you all, some familiar faces and some people just whose names I know, but I wish I could meet. So anyways.
All right.
All right, so thank you, everyone. Thank you, Joel, for presenting the paper. I just wanted to mention that we are going to have our next seminar in 2 weeks on April 23 with Avi Goldfarb presenting. And I hope to see many of you, or basically every one of you, in 2 weeks. Thank you.